Dear students, in this video we are going to see few properties of group and few more problems. Okay, now let G comma star be a group. Okay, having these 7 properties, but here we take this group Z comma plus. Already we proved. Okay, in the previous videos we have proved Z comma plus is an abelian group. Okay, abelian group means already it has satisfied 4 properties, so it is a group. Okay, now you see what is property 3. For all a comma b belongs to G, we have a star b whole inverse is equal to b inverse star a inverse. Okay, now here I take z comma plus, so my binary operation is plus. Okay, I take any element, any 2 elements in z. Okay, that is a and b. Here I am taking a as 4 and I am taking b as minus 9, and then I am checking this. Okay, actually this property is true. These are the properties, it's true, but just I'm explaining how to verify this. Okay, now you see here a is 4, so what is a inverse? This is here addition. The binary operation is here addition. So what is the inverse of a 4 is minus 4. Inverse of 4 is minus 4. Inverse of minus 9 is plus 9. Okay, because I need inverse of a and inverse of b. Okay, now here I had to multiply, sorry, I had to do binary operation of a and b. See here binary operation is plus. So what is it? A star b, first I have to find a star b, then inverse. So what is a star b? A star b is nothing but a plus b is equal to a is 4, b is minus 9, therefore minus 5. So a star b is minus 5. So what is the inverse of this? The inverse of minus 5 is plus 5. Okay, by this rule. Okay, so inverse is nothing but minus of the element, so plus 5. So now here I found a star b whole inverse. So a star b whole inverse is nothing but 5. Okay, 5. Then b inverse I know that 9. Then a inverse I know that minus 4. So now you check this property. Actually this is property 3. Okay, now this is 5 is equal to b inverse is 9 plus a inverse is minus 4. Okay, here star is the binary operation in the general case. Now here binary operation is plus. So that now you see 5 is equal to 5. The property is true. Similarly, you can verify any property. Okay, similarly you can verify any property. You can verify the property through z comma plus, or you can take any group. Then you take some elements to verify it. Okay. Now we'll see this problem. Example 1. In the group z6 comma addition modulo 6. See, this is addition modulo 6. Already we are seen in the previous video. Okay, what we have to do, show that z6 is closed under addition modulo 6. So for that, first I make the list of elements and the table column for this. Okay, now here what are the elements in z6? First you have to understand, you have to write what are the elements in z6. See here z6, what are the elements in z6? 0, 1, 2, 3, 4, 5. Okay, because here z suffix value is 6, so you have to write until 6 minus 1, that is 5. Okay, so 0, 1, 2, 3, 4, 5. So you make table column here. 0, 1, 2, 3, 4, 5 you write, and 0, 1, 2, 3, 4, 5 you write it here. Okay, now what is the binary operation? That is addition modulo 6. Okay, so what you do addition modulo 6, already I told you. What you have to do, see, first you add these two numbers. See, 0 you add with 0, then 0, because if you apply the modulo 6, because this is small number, smaller than 6, so your answer is same. 0 and 1. See, whenever you get the addition less than 6, you write the number same as it is. Okay, now 0 0 you add 0, 0 1 1, 0 2 2 you add, 0 3 3. Okay, now you take 1 1 0 1 1 1 2 1 2 3. Similarly you see the last one 1, you see here 1 you add with 5, so 1 plus 5 6. Okay, now it is equal to this modulo. So now what you do, when you get 6 or more than 6, you apply this modulo. Then what is the remainder? You have to see, for example you are getting 6, so what you do, 1 multiply 6 plus 0 like this you write, then you write the remainder here. That's what I'm telling. Now you see here 2 plus 0 2, that is smaller than 6. But you see 2 plus 3, for example, you take 2 and 3, 2 plus 3 5, that is also smaller than 6. Okay, you take 2 plus 5 7. Okay, 2 plus 5 is 7. So 7, what you do, 7 is equal to 1 multiply 6, 1 multiply 6 plus remainder is 1. So you are writing here. Okay, likewise you can fill the table. Okay, now this is called, means what is the first constraint? So that Z6 is closed under addition modulo 6, which means, say you take any two numbers, apply the binary operation, this answer again inverse that, yes, because you see here what you are getting after applying the addition modulo 6, 0 1 2 3 4 5, from 0 to 5 only you are getting all the answers here. Okay, so that it is closed. Okay, now from the above table it is clear that the identity element of the group is 0. Yes, because this is addition modulo 6, so that identity element is 0. Okay, that is addition, identity element for addition is 0. Okay, from the table we can identify that. Okay, the inverse are given in the following table. Okay, that question is find the inverse. How to find the inverse? Okay, this is what given in the previous video. Okay, it is given here. How to find the inverse of this type of groups, z6 comma addition modulo 6 or zn comma addition modulo n. How to find the inverse? See, inverse of b is n minus b. What is n? That is in your question what is given here. N is 6. Here n is 6. Okay, so now you take the element 0. You take the element 0. Now you see the rule here, what is given. See, inverse of 0, how to find? You see, n minus 0, it will become n cap, but it is equal to 0 cap. Okay, because the elements here we have from 0 to n minus 1. Okay, now see, you apply this rule. You see here, so that inverse of 0. See, you take b as 0, then what is the inverse? That is n minus 0. So n minus 0 is n cap, that is equal to 0 cap. So you are writing here inverse. Okay, you apply this rule, you can write the inverse directly. See here, what is the inverse of b1? See here, inverse of b, here b is 1, so inverse of b is 6 minus 1, because here the given set is z6. Okay, so now here to find the inverse of 1, just you go here, apply n is equal to 6 minus what is your b? B is 1. So 6 minus 1. So 5. What is the inverse of 2? 6 minus 2, 4. What is the inverse of 3? 6 minus 3. This is 6 minus 4. This is 6 minus 1. Because here is at 6, n is 6. Okay, similarly you can complete the table. Now we'll see another example. In the group z7 minus 0 multiplication modulo 7, show that this is closed under multiplication modulo 7, and then find the identity element and then find the inverse of each element. Okay, now you see here, first we have to list out the elements. So that see z7 minus 0 is nothing but you start from 1, because here we deleted 0. You start from 1. 1 2 3 4 5 6. Here 7, so 7 minus 1 is 6. And you have to understand one thing here, this is z7. 7 is a prime number. Okay, we have discussed it in the previous video. Okay, so now you write all the numbers from the given z7 minus 0, 1 2 3 until 6. Here 1 2 3 until 6. In make a table. Okay, now we have to show that this is closed. How to show that it is closed? You take means 1 and you operate with this one under this operation multiplication modulo 7, which means 1 multiply 1 1 multiply 2 2, because here 1 is smaller than 7, so no need to apply the modulo 7. Okay, 1 multiply 2, so here 2. 1 multiply 6 until it will give the same number. Now you see here 2 multiply 4, how much? You see here 2 and you take 4. 2 multiply 4, how much? 8. Okay, this is bigger than this multiplication modulo 7. So what you do, 8 is 1 multiply 7. What is the remainder? Is 1. So this remainder you write it here. If when the product comes bigger or equal to 7, then you do this. So now you see here 2 multiply 5, how much? 10. So 10, what you do is equal to 1 multiply 7 plus the remainder. Remainder is 3. So that you are writing here 3. Understand? Similar way you can fill this table. Okay, for example, you take 5 and 4. How much? Here we are writing 6. How? 5 and 4. 5 and 4. See, 5 and 4 is 20. So 20, you play the modulo 7. 7 multiply 2. 2 times 7, 14. Plus what is the remainder? 6. That's why we are writing here 6. Okay. In a similar way you can fill the table. Okay. Now after this, the above table shows that we know that for the multiplication, what is the identity element? Is 1. So now here identity element is 1. Okay. This is the identity element. Okay. Now you see the inverses are given in the following table. Okay. How to write the inverse? See, for this, here we have means followed the rule, then we have written the inverse. Okay. Now in other words also we can write the inverse of this. You see here, wherever you get 0, you see here, you mark circle on 0. Wherever you get 0 on the table, if you do all these 3, then from the first table you can write inverse also. See here, 0. If 0, here you see the corresponding row and column. You see here 0, here 0, means this element is inverse of this, or this element is inverse of this. Okay. Now for example, you see here, you see this, the identity element. Now you go see here, this 2 is the inverse of 4, or we can say 4 is the inverse of 2. You see here the answer. See, inverse of 4 is 2, inverse of 2 is 4. Okay. In a similar way you can write. Okay. Here we have tried the inverse of each element. Okay. 1, 2, 3, 4, 5, 6. Okay. Now here you go and mark 1 because identity element is 1. Now you see here I marked this 1. So inverse of 2 is 4. Inverse of 4 is 2. Now you see I marked this 1. Inverse of 5 is, go here, 3. Inverse of 3 is 5. See, that's what you feel. Okay. Or we can use this rule also, how to find the inverse. Or actually what is given in the, see, inverse of an element A is the element B, then such that A multiplication modulo P, B, B1. Okay, the element and the inverse element, if we apply the multiplication modulo, then should give the identity element 1. Okay, that's what we have checked here. That's what we have checked here. You see here, you see here 2 and 4. When you operate these two by the given binary operation, it's giving 1. See, 2 and 4. When you apply the binary operation, your value is 1. That is identity element. That's why the inverse of 2 is 4, inverse of 4 is 2. We see another question. You see here, we have to find the inverse of each element of z11 minus 0 multiplication modulo 11. We know that what are the elements. Elements are 1 to 10. Okay, because here z11 minus 0. So 1 to 11. You list all the elements. Here we have to find only the inverse. See this rule, b inverse is equal to 11x plus 1 by b. X is equal to nothing but 0, 1, 2, 3, etc. Any value. Now first we find the inverse of 1. B is 1. See, first number. So B is 1. You first try here x is 0. Okay, x 0. So x 0 you put. So 0 plus 1 by 1 is 1. So B inverse is 1. Okay. Now for B is 2. For B is 2. Now try x is equal to 0 for B inverse. So B inverse is equal to 11 into 0 plus 1 by 2. Here you are getting 0.5. So it is not allowed. So it is in decimal. So this is not the inverse. So now try another value. See, we have tried x is 0. We are getting wrong. So go to next value. X is 1. So put x1. So you are getting 6. So that is the inverse. Similarly, you can find the inverse for all the elements. You try x0, 1, 2, etc. Thank you.